All right. Hi, everybody. I hope your weekend is going well. I hope the pep rally was good. And I hope I do a good job explaining this because it's, about 5 o'clock Friday, and I am pretty beat. But I'll do my best, and hopefully we'll all be on the same page come Monday. All right. This is on page 1 of your notes, and we're graphing rational functions. It's in the yellow packet. Sorry about the yellow packet, the way the holes were punched, and there are repeating pages in it, but whatever. We'll get you a better calendar, and we'll keep rolling forward. So anyway, I want to start out with this that we kind of added last year. It's a definition for a rational function, and I felt like it ought to be here in the event that it should, I don't know, show up on a test or something. You never know. And what a rational function is, it's a ratio, hence rational, with a polynomial in the numerator and a polynomial in the denominator. All right, so that seems pretty straightforward and something you should forget quickly. But what if you get a function like f of x equals x minus 2 over the square root of x plus 3? And you are asked if that is a rational function. Well, the numerator is a polynomial, but the denominator, if you think about it, can be written x plus 3 to the 1/2 power. And basically, that is not a polynomial because polynomials only have integer exponents, well, actually, whole number exponents that are greater than 1. So, yeah, that's not going to fly. That is not a rational function because it is not a polynomial in both places. Okay, so enough of that. The rest of this, I will be happy to read it to you, except that's a good way to put you to sleep. These are all of the rules for how to graph a rational function, and that is the objective for what we're doing. So we can refer back to these things, and they have a list of all of the things, but I think what we ought to do is just dive in and do it, and then we'll just kind of pull up what the rules are as we go. So here is the first example. It's a pretty basic one. It's you've got polynomials that are already in factored form. So if you look at this numerator and this denominator, you cannot divide anything or cancel out a factor from the top to the bottom, from numerator to denominator. So that's where the holes come in, the removable discontinuities. So since that can't be factored and reduced, we'll just put none for holes. Okay, so that's a good start. And the next thing we need to do is kind of look at the domain and at least like the vertical asymptotes. So looking at your denominator, that is what determines your vertical asymptote. And so you ask yourself, if you're going to put a vertical asymptote here, all right, so what value will make that that expression go undefined? And that's when x is 1. So you have a vertical asymptote where x is 1. That is also going to be a break in your domain. Normally, you might have another one if you had a hole, but we don't have that. So this is going to be from negative infinity to 1, and it'll break there and then go from 1 to infinity. So there's your domain. And while we're at it, we should be able to just go ahead and start marking this, because if we know that that is going to be a vertical asymptote, then why not mark it? And so this will be at x equals 1. Always got to label these things. So then we have horizontal asymptote. So what's the rule for it? Oh, who remembers? Nobody. So let's go back and we'll look at this. And if I can get this to work. Horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, that's not going to be it. If the degree of the numerator equals the degree of the denominator, I think that will be it, because looking at this, the degree here is a 1, and the degree in the denominator is also 1. So what we do then is take the coefficients. That didn't line up too well. It looks like my calibration might be off. So it's this over this, so it's negative 3 over negative 1, which is just y equals 3. So we have a horizontal asymptote at y equals 3, and we can just go ahead and mark that here. All right, so we're good there. Intercepts, let's get all the mess off of here. For your y-intercept, that's where x equals 0. If we let everything here for x equals 0, we just get 1 over 1. So this is going to be 0 and 1. So we do have a y-intercept at 0, 1 right there. And that kind of determines where this branch is going to go. It'll be kind of in this lower left quarter of this particular graph. So then we can have x-intercepts. And the x-intercepts, if you look back on your little list of rules from the front page, you get it from your numerator. So we'll just put numerator here as a reminder. So you take your numerator, 1 minus 3x, and you set that equal to 0. So you subtract your 1 over, negative 3x equals negative 1, so x equals 1/3 when you divide that out. So your x-intercept will be 1/3, comma, 0. And that will be this little guy right here. A little hard to draw it accurately, but that's pretty good. Okay, so really we're going to definitely get a branch in that area. All we need to really do before we draw it is to make sure that we don't have a situation where the graph actually intersects the horizontal asymptote. So the way that we do that is, and I'm going to indicate that I will do that work here, is if you look at the front, you take what you have for your value for your horizontal asymptote and you set it equal to the function. You solve it. If it solves and gives you an x equals some number, that's where it crosses the horizontal asymptote. Otherwise, if it doesn't solve, then it won't cross at all. So we'll just do 3 equals, and let me see what that problem was. What was it? 1 minus 3x over 1 minus x. All right, so we'll just multiply each side by 1 minus x, here too. All right, that'll cancel out. We're going to get 3 minus 3x equals 1 minus 3x. And if you add the 3x over, you get just a nonsense thing. You get 3 equals 1, which is not true, so it does not cross, it does not intersect your horizontal asymptote. So this is no. All right, at this point, we are ready to draw in at least this particular branch. So it looks like this. Okay, so extra points are used for when we either need to clean up the graph and make it look good, or if we need to check to see where in the heck the other branch goes. So the other branch has a chance of being either here, up in this upper quarter, or down here. So what we need to do is check an x value that goes on the other side or the right side of that vertical asymptote. So I'm going to plug in a 2 for my extra point and then see what the output is. So if I do x equals 2 and process f of 2, that's going to be 1 minus 3 times 2 over 1 minus 2, which is going to be negative 5 over negative 1, or 5. So that's going to give me the point 2 comma 5. I don't want to take up all of this space with work. I think you get the idea. And so that's going to create, let me pull this back down, that's going to create a branch wherever that point is. So over 2 and up, 1, 2, 3, 4, 5 is here. And so our branch is like so. Okay? So really our graph is complete at that point. We just need to do 2 other things. All right? We need to figure out the end behavior. So I'm going to put this here, and what you're going to see here is, let's see if I can get that out of the way, as x goes to the right, y is dropping down to where y equals 3. So f of x equals 3, or I'm sorry, let's say it approaches 3 as x approaches infinity, or as it goes to the right. And as it goes to the left, this way, towards negative infinity, you can see that this red curve is going up towards 3. Again, it's just approaching it from the other side. So as f of x will approach, that should be a 3, that should be a 3 as x approaches negative infinity. All right? So f of x approaches 3 as x approaches infinity on the right. F of x, or y, approaches 3 as x approaches negative infinity on the left. Okay? So last thing to look at here is the sign, or the sign analysis. Very, very important. So you've got to get this right. It is part of the process. So intervals. We're going to make intervals from vertical asymptotes and from zeros. Now you can do holes if you want to, but we're looking to see where the graph is going from negative to positive. And typically, when a hole shows up, it's going to be either above x or below x on either side of the hole. So it really doesn't enlighten you as to what it, if there is a change in sign at a hole. Normally there isn't. It could happen, but it's pretty rare. All right, so looking back at this graph, whoops, let's undo that. Okay. We have a 0. Everything goes from negative infinity until we get to that 0. So that's going to be our first interval. Oh, check that. That's a y-intercept. We actually had one here at this 0 here at 1/3. So this, let me undo that. Okay, so this one will be from negative infinity to negative 1/3. All right, that was our first 0. And then we had a vertical asymptote right after that. Check that, it was positive 1/3. So that's going to then go from 1/3 to that vertical asymptote, which is 1. Okay? And then it's going to go from 1 to infinity, because there's really nothing after 1. So we got to check those intervals. What you do is you take the factored form that we came up with, and we're just going to list the factors. So, well, actually, we didn't need to factor this. So 1 minus 3x was in your numerator. I'll just put this down here to remind you. You don't have to write that normally. And then 1 minus x was in your denominator. And the two of them together make f of x, right? So what we need to do is just check a value. And you don't want a value like one of the ones that you're seeing in your interval. You want something that's off of the edges. So I'm just going to plug in a 0. So if I put a 0 in here, I'm just going to get a 1, and 1 is positive. And if I put a 0 in here, it's just 1 minus 0, and that's 1 also, and that'll be positive. And in a fraction, positive over positive is positive. So this, the very left part of your graph, should be above 0. All right? So then here, I'm going to put in a 1/2. So 1 minus 3 times a half, is going to be 1 minus 3 over 2. That'll be negative. 1 minus a half on the denominator part will be 1/2. That's positive. In a fraction, negative over positive is negative. So this will be below 0. And then here we can just pick almost anything. I'm just going to pick something simple like 2. So that'll be 1 minus 6 is negative. That'll be 1 minus 2 is negative. In a fraction, negative over negative is a positive. So that'll be above 0. All right? So if we scroll back to this graph, it should match. Above, right here. Below, right here. And then above, right there. See how that works? Okay, let's try another one. All right, this is the second example. And I'm going to start out by factoring this denominator. So x minus 2 times x plus 1. And there's not going to give me, this will not give me any factors that will reduce numerator to denominator. So there are no holes. There are, however, 2 breaks in your domain. So that'll be from negative infinity to 2. Oh, check that. I guess it's going to go. If I list my asymptotes, you'll see it a little better. So your vertical asymptotes here, x equals negative 1, x equals 2. All right, that'll make the domain a little easier. So this will be negative infinity to negative 1, and then from negative 1 to 2, and then from 2 to infinity. Okay? And we can put in those asymptotes right now. So here's your x equals negative 1 asymptote, here and here. And here's your x equals 2 asymptote, right? And, okay, horizontal asymptote. This is degree 1, this is degree 2. It's bigger in the denominator than the numerator. So by rule, y equals 0. So we can put that in. And you can see we're going to end up with 3 branches here. That makes it a little complicated, but no big deal. We'll handle it. Okay, intercepts. You may need those factors again. We'll get them later. The intercept here, if I just plug in for my y-intercept, if I let x equal 0, then it's going to come out 0 over negative 2, which is 0. And that's going to be the same for the x-intercept, because that's just from your numerator. You set that equal to 0, and boom, you've got it. Y is automatically 0, so it's the same point. So that's this point right here. That is right on your horizontal asymptote. So it looks like we have a situation where it's going to cross your horizontal asymptote. Okay, and we can check that. We can check that here with the intersection. All right, and remember, it's the value of your horizontal asymptote. 0 equals the function. That'll be x over x squared minus x minus 2. So I'm going to multiply each side by that. Right, multiply this by it too. Right, that's just going to be 0. This cancels out, equals x. So yes, you're going to have a cross of that horizontal asymptote where x equals 0, which we already found. Okay, so I'm going to find some extra points, and I'm not going to show you all of the math for it. It probably wouldn't hurt to have a calculator with your store function handy. So I'm going to try over here on the very left of this, figure out whether the branch is above y equals 0, better mark that, or if it's above it or below it. All right? So I checked a negative 2 because that's beyond your vertical asymptote going to the left, and I got a negative 1/2. That's going to be right here. Let me put that in a different color. That's going to be right here. All right? That is going to determine your branch as so. Okay? So now I'm going to do the far right, and I'll save the middle part for later. So I checked where x was 3, and I got 3/4. So that's going to be over 3 and up 3/4. That's right here. That determines another branch, like so. All right? So now this middle part where I have the red um, mark on the origin, that will either look like a chair or it'll look like a parabola, like kind of like a little tiny parabola. So I'm going to check a point to either side of it, where x equals 1 and where x equals a half. So when I checked x equals 1, I got negative 1/2. All right, and so that point is going to be right here. And then I checked where x was negative 1/2, and I got an output of 2/5, which will be somewhere like right here. And that's going to determine your branch will look like a chair, like so. And the sign analysis will confirm that. All right, so when we get to that, you'll see it. But for right now, let's get some, I'm going to erase this. Hopefully you wrote it. If you didn't, you can always go backwards and see those points again. I'm going to go ahead and do the end behavior. And the end behavior doesn't, you don't worry about that middle piece, that middle branch. It's just the leftmost and the rightmost. So going to the right, as x goes this way, y is dropping down to 0. So f of x approaches 0 as, not x, as x approaches infinity. And f of x also approaches 0, when we look at things going this way, as x approaches negative infinity. All right, so end behavior is a little bit different when you're talking about rational functions as opposed to the polynomial functions. Okay? All right, so hopefully I'm not going too quickly. If I am, just pause things as we go. And let's see, if you look back at your graph, we did have a, let's see, we had a vertical asymptote at -1 going left to right. So that'll give us negative infinity to -1. And then we had a 0 at 0. So that would be -1 to 0. And then we went from there to 2, so 0 to 2. And we kind of didn't have enough room for this. You're going to have to use this for 2 to infinity. Okay? And looking at this, our numerator was x, right? And in the denominator, we had two factors, x minus 2, x plus 1. And those two things are denominator. And so they kind of go together because they are multiplied to each other. And that's going to make a sign issue for when, we have to figure out whether it's positive or negative. So I'm just going to drop in a -2 here. So if I put a -2 for this x, this top one, it's going to go negative. If I put a -2 in the next one and subtract 2, that'll be -4. That's negative. And if I put a -2 in the third one, it'll give you a -1. That's negative. However, these two things are in the same part of the fraction. They multiply to a positive. So negative over positive is a negative. This is below. Does that make sense? All right. For this one, I'm going to put in -1/2. Right? So if you plug that in for x, it's negative. If you put it in for x minus 2, it's negative. If you put it in for x plus 1, it's positive. And remember, these two go together. So negative times positive is a negative. Negative over negative is a positive. So this is above. Okay? So process that for a second. Here I'm going to put in a 1. So if I put 1 in for x, that's positive. 1 minus 2 is negative. 1 plus 1 is 2, that's positive. These two things are products of each other, so that goes negative. Positive over negative is negative. This is below. And then here, I'm just going to pick the number 3. And so if I put in x for 3, that's positive. 3 minus 2 is positive. 3 plus 1 is positive. Everything is positive. This is above. All right? So below, above, below, above. Let's check that. Below, above, below, above. That's below the x-axis. Okay? So I'm going to go ahead and stop this, and I think I'm going to make a second video for the last one, and stand by.